Welcome to module 3 of programming in C++. This module will discuss about arrays and strings. We have in module 2 seen what are the basic differences between a C program and a C++ program. We will continue on the same note, and in this module we will try to particularly understand the use of arrays in C and C++. We will introduce a basic notion of what is called vector in C++, which is pretty much like arrays, but lot more powerful, and we will try to see how strings are used in C, and in contrast how the string type operates in C++. So, these are the points that we will cover. So, to get started, we have side by side shown two programs, both of them they actually are identical except for the difference in the IO header. So, a basic use of array as in C can be done in C++ exactly in the same notation and with the same meaning. So, the first message is arrays can be used in C++ exactly as you know as in C. So, here we are just assigning some values to the different array elements and printing them. Only difference is in terms of using the printf or using the cout. Now, one of the main issues in C in terms of using arrays that you all must have faced is when I want to use an array in C, I need to specify the size of the array, which means that the maximum number of elements that the array can contain beforehand, that is at the time of writing the program, or to be specific at the time of compiling the program. So, if I do not know that size, then I need to provide a size which is greater than what can happen in any one of the cases that I run in the program. And certainly, there are two ways of handling this situation. One is I declare a large array, and this can be either hard coded, the size can be hard coded within the program, or the size can be somewhat soft coded by using a manifest constant. And the other case that you have seen earlier in C programming is you could use malloc to dynamically allocate space and allocate the array at the runtime, and then use it. And if you are using malloc, you will also have to remember to free it up when your use of that array is done. So, let us see how does this look in terms of as we migrate from C to C++. So, this is just showing the C example. On the left hand side, we are hard coding the size of the array ARR to 100. On the right column, we are doing the same thing, except that now we have a manifest constant max, which is defined to have a value 100, and we are using that max. The advantage of using the manifest constant is there could be 10 different arrays whose sizes are to be specified to 100. Now, if I hard code all of them and sometime later I need to change all those sizes to from 100 to 1000, that at 10 places I will need to go and edit, and I might just forget to do all of them. But if I hash define or use a manifest constant, then I can make the change only at one place, change the definition of max from 100 to 1000, and all of those will change. So, it is a better programming practice in C to use manifest constant and not hard code values. You already know this. Now, we show the similar situation in between C and C++. On the right column, now you have a C++ program. Certainly, the array size, the maximum array size as max can be hash defined to 100 as has been done. But what we show here is just focus on the line right after the header of main. We are writing vector within corner brackets int and then the array name, and within parenthesis we show the size max. Vector is a new introduction in C++. This is not a built-in type. Please do not consider this to be a built-in type. This is something which is provided by the C++ standard library. So, if you move your attention to the top in terms of the hash include list, you will find there is a hash include vector. So, there is a standard library header vector which has all the necessary declarations, definitions for a vector type, and you can use that in this way. What it means is vector for in all respect work like arrays. They can be, so you just focus within the for loop, you see how the array elements are being accessed. On the left hand side, it is a well known array int arr, we write it as arri. On the right, it is a vector of int, we use the same indexing notation to access the array elements. So, vector is same in terms of access notation and the result of doing the read or write access with the traditional array, but it has the advantage that its size is not necessarily fixed at the compile time. Now, in this example, we have just shown that how to use vector with a fixed initial size max. So, when we say vector and within corner bracket int, what we mean that within corner bracket we are providing the type of the element that the array is composed of, which is what we write in C as int arr. We write it as vector within corner bracket int, and whatever we provide as a maximum size within the square brackets, here we pass it as a parameter after the arr name. So, this is just a notational difference. Right now, just accept this as a different notation of writing declaring arrays, and once you have done that, rest of the program you can forget about that you are specifically using a vector, you can just continue to use them as arrays. Now, with this, let me show where you actually get the advantage. Now, let us focus on the second mechanism of using arbitrary sized arrays, that is, you do not know at all as to how large an array can be. You will get to know only when the program is executed by the user. So, the user will probably provide the size of the array, the number of elements that the user wants. So, on the C program on left, you see that the first we are asking the user how many elements are there, and the user provides a count value. And if you have to do this in C, then you will have to dynamically allocate the array using malloc as is shown and proceed with that. Certainly, you will need to write a very complex form in malloc, because you really need to say how much memory you want. Malloc returns you a void star pointer, you need to remember and cast that to int star. All those nuances of C programming exist. Now, just shift your focus to the right on the same lines. Now, we are declaring the variable as a vector of int. The variable is arr, and please note, in contrast to what we had shown earlier, we are not passing any max size. So, if we do not pass a max size, then we get a vector of a default size. The C++ standard library will have some default size, which is not fixed, but some default size array will be there. But the following line, we write something which you are not familiar in the notation. We are writing arr dot resize. We call this as resize being a member function of the vector type. What it does is, in this resize function, if we pass a value as we are passing through the variable count, then the vector will resize to the count number of elements. So, let us assume that the default size with which the vector was created is 10, and now the user at the runtime has given an input 100 to count. So, when arr dot resize is done, the value will be passed as 100 and the vector will change to having 100 elements from the original 10 elements. So, resize can be used very conveniently to increase or decrease the number of elements that a vector can have, or for that matter the vector form of array can have. So, with that you get rid of using all this malloc and its complicated notation and remembering to free that location and so on. You can just use vector and resize them as needed, which makes the use of arrays in C++ programs as a vector container is far more convenient and compact than the similar mechanisms in C. Next, let us take a look in the handling of strings. As you would be already familiar that besides the numerical types, that is the whole numbers, int and the floating point numbers, the next most widely used and most required type of values that we need to deal with are strings, where we are talking about a sequence of characters. And what do we have in, if we are working in C, we have what is now called a C string. C does not have a default type as string, but it has a string.h standard library header, which provides a whole lot of string functions like strlen, strcpy, strcat and so on. And with that, C string is just an array of characters which we say is terminated by null, which means that if you scan the array from left to right, you will continue to consider that you have a string till you come across the first null character or the character with ASCII value 0. Please note that in the array after this null there could be several other characters still remaining, but they are not considered to be part of the string. Now, with this convention, if you use the string functions from string.h header, then you will be able to achieve variety of string operations, as you all are familiar with. In contrast, C++ now introduces a string type in C++ standard library. This is pretty much like we talked about vector. So, string also is not a built-in type, but it is a type added through the standard library, and you will have to use the string header of C++ standard library to get the strings, and it has some amazing behavior like being able to write concatenation of strings as an addition expression. So, we will illustrate those. Here is a simple parallel between a C program and a C++ program. These programs start with two strings that are defined within the program, the hello world, and we want to concatenate the second string after the first string. So, we just want to put them side by side, the first string followed by the second string, and make one concatenated string. So, if you have to do that in C, on the left you can see what you will need to do. You will need to have an array large enough to contain the concatenated string, let us call it str. You will have to copy the first string str1 into str, and then you will have to concatenate str2 into what is already copied in str. So, it will just come after that. So, first hello followed by a blank will get copied to str, and then world will get concatenated, strcpy and strcat does the job, and then you can print it. In contrast, in C++, you have a string type in the string header. So, you include the string header. Now, you do not declare them as character arrays, you declare them as string, which is the name of the type given in that header. Please note that this name is all in lower case, and then you have the string variable name str1, and you initialize it with the constant string hello blank or world. The very interesting thing is, now when you have to concatenate, you do not really need to copy the first string and then do concatenation. You can just say that I am adding str2 to str1. So, you say str1 plus str2. So, this is pretty much like I have a variable x having value 3, I have a variable y having value 5, I write x plus y to mean 3 plus 5, which is 8. So, that is an integer addition. This is kind of a string addition in the type of string, this becomes a concatenation operation, and we will see the amazing power in C++ to be able to define operators for your own types in whatever way you want to interpret them. For example, you could use this to write an algebra for rectangles. You can have two rectangles if you have a rectangle type, and you can define that the addition of two rectangles is basically making a union of these rectangles to make a rectangle large enough to contain both these rectangles and so on. So, this feature in terms of string is available in C++. Therefore, it becomes really easy to deal with strings in C++. Particularly note that in C you will really need to know what is the size of the result, so that you can define again an array large enough for the variable str, because if this is str is not enough in size, then strcpy or strcat later on will fail. In C++, you do not